Now that we've converted from expanded to factored form and factored form to expanded form, we're going to look at finding the domain of each of these functions. And remember, we've talked about domain and range in class, whereas domain is what you can plug into a function. It's your input, and a range is what the output is. So when we talk about domain and range, the domain is your x value. What can I plug in? What can I input for x? And when you're dealing with rational functions, you're limited on what you can input for x because you are in fraction format. And what is the one thing we cannot have in the denominator of a fraction? 0. You cannot divide by 0. So here's the rules. You cannot divide by 0. Okay? In a fraction. So we cannot have 0 in the denominator. So no 0 in the denominator. No 0 in the denominator. We cannot have it. In the example I like to use when we're doing domain and range, input and output, is like a vending machine. Okay? If you were to have a vending machine, just imagine any kind of vending machine you may have. And let's say if you have a vending machine, then what you're going to be using for a vending machine, the domain for a vending machine is the money you can put in. That's the domain for a vending machine. What money can you put in there? The range for the vending machine is your output. Okay? That's the product you get. The product received or dispensed, however you want to say it. So let's think of a vending machine. So let's look at some vending machine examples, just some simple examples. Let's say I have a Coca-Cola machine. All right, if I'm looking at a Coca-Cola machine, what would be my domain? What can you input into a Coca-Cola machine? Well, it's very specific. You cannot put every kind of coin or every kind of currency in a Coca-Cola machine. So what are some things you can put into a Coke machine? Well, let's look at coins first. You cannot put pennies, okay? So your domain, X, could not be pennies. Pennies don't work. Now, what we could put in, we can put in nickels. We can put in dimes. We can put in quarters. Okay, nickels, dimes, and quarters. Can we put in a 50-cent piece? Nope. So that's not in the domain either. So your domain is going to be nickels, dimes, and quarters. Now, let's look at currency. You can put in a $1 bill. You can put in a $5 bill. Most machines don't accept anything other than those two. So it can't be a $2 bill. It can't be a $10 bill or anything higher than that. So that's your domain. Your domain is what can I put into the machine? What is my input? What is my working input? So now let's look at the range. So the domain is all this money. The range is going to be your output. That's going to be your output. And so we'll go back next to domain and we'll put input because that's your input. Okay? So you got your input and you got your output. So let's look at the output. The range, which is the output, is going to be for this one basically any Coca-Cola products that are in the machine. Any Coca-Cola products that are in the machine. What can your range not be? Pepsi? Pepsi products, right? Can't have Pepsi products, all right? There's certain things that are not Coca-Cola products. So Y is going to be you can't have Pepsi or anything that is not a Coca-Cola product. So that is how you figure out your domain and range. Let's say you're looking at a vending machine. If I look at a vending machine with snacks, with food in it, you're not going to be able to put money in a snack machine and get a soda out of it. what you put in is your input. The output's going to be chips, gum, pastries, whatever's in that machine. That's going to be your range. So that kind of gives you an idea of what domain and range are. And when we're looking at these functions, it's very important that we know the domain, and we can tell the domain because they're fractions. And what can we not do in fractions? Divide by 0. We cannot have 0 in the denominator, so that cannot be part of our domain or our input. It's like the vending machine. What can I not put into a vending machine? Well, I can't put pennies or a 50-cent piece or anything other than $1 or $5 denomination currency in there. So let's look at our rational functions here. And we're going to look at the domain, and we're going to have the domain in brown. Okay? So let's look at these functions. First one, the domain, I can pretty much put anything in here I want except for what value? Well, if you look here, the numerator of my denominator of my fraction is x plus 2. If x is negative 2, that makes the denominator 0. So just to kind of show you, this is number 1. Just to kind of show you on number 1, if I have x minus 4 over x plus 2, the one thing I know is that x plus 2 cannot equal 0. If it does, that makes the denominator 0, and we can't do that. So I have to find out what is the one value that will make this 0. And when I solve it, I get negative 2. So your domain is all numbers, but x cannot equal negative 2. That's all you have to put. X does not equal negative 2. If you want to put all real numbers, you can do that as well. But for right now, I just want to know what our restrictions are for the domain. What can x not equal? So let's look at number 2. Number 2, you have x plus 6 over x minus 6. Now, once again, we don't want the denominator to be 0, so we have to find out what it is that would make x minus 6 equal to 0, and then that is our restriction. So to solve it, that means if x is 6, that makes this 0. That would be x plus 6 over 0. No, we can't do that. So for number 2, x can be anything except 6. Kind of getting the hang of this now. So let's look at number 3. Okay. Number 3, looking at the same thing for number 3. On number 3, we have 2x plus 5 over x minus 1. So x minus 1 cannot equal 0. So we're going to find out what it is that makes it 0. I'm going to add 1 to both sides, so x equals 1. If x is 1, that means I have 2x plus 5 over 0. Can't do it. So that means that x cannot equal 1. That's our domain. Everything except 1. Let's look at number 4. Number 4, we have, I'm going to kind of save you some time here. We're just going to do the denominator. We need to find out what it is that makes negative x plus 1 equal to 0. So I'm going to set it equal to 0 here. I'm going to move the 1. So I get negative x equals negative 1. And since it's negative, I'm going to divide both sides by a negative to get positive. So x cannot equal 1. Now I'm going to go ahead and put these here. X cannot equal 1. So you should be getting the hang of this by now to figure out what your limits are on your domain. So let's look at number 5. Number 5 is a little bit different. So I'm going to move the paper over here. We'll do number 5. And number 5 is x plus 4 over x times x plus 4, I believe. Yes. Okay. So when you look at this one, there's a difference. Notice how all of these had a single factor in the denominator. This one has 2 factors, which means there's going to be 2 restrictions. So I've got 2 separate factors. I got to figure out what makes each of these factors equal 0. The first one is x. Well, that's easy. X, if x is 0, there's nothing to set it equal to, so x can't be 0. The next one is x plus 4. How would we make that a 0? Well, I have subtract 4. That means if x comes out to negative 4, that would be 0. So you've got two situations that don't work. So x cannot equal 0 or negative 4. So now you've got two values. And what you're going to see subsequently in all these is that we've got two values that don't work for x. So let's look at number 6. I have x plus 1 and x minus 3. You should be able to figure out the pattern by now. X cannot equal negative 1 because negative 1 would make x plus 1 0. And x cannot equal 3 because x minus 3, 3 minus 3 would be 0. For number 7, x cannot equal 2 because x minus 2, 2 minus 2 would be 0. And x cannot equal negative 1 because negative 1 plus 1 would be 0. In number 8, x cannot equal negative 2 because negative 2 plus 2 is 0. And x cannot equal 1 because 1 minus 1 is 0. Okay. In number 9, x cannot equal negative 3 because negative 3 plus 3 is 0. And x cannot equal 2 because 2 minus 2 is 0. And in our last one, x cannot equal negative 2 because negative 2 plus 2 is 0. Apologize, let me move that up. And x cannot equal 1 because 1 minus 1 would be 0. And that is how you find the domain of a rational function using the denominator.